Venus destroys everything humanity sends to it. Pressure crushes metal. Heat erases electronics. Any engineered system exposed to that environment is pushed to its limits within minutes. And yet, from 1961 to 1984, the Soviet Union kept returning, launching probe after probe into Venus's atmosphere, more robotic missions than any other nation in history. What made a superpower obsess over a planet that offered no glory, no landing, and no possibility of conquest? And more importantly, what did they gain from failure after failure? The answer wasn't success. It was data so extreme that it reshaped planetary science and is now driving a renewed push to return to Venus in the 2030s. To the naked eye, Venus is a masterpiece of deception. For millennia, astronomers called it the morning star, the jewel of the sky, and named it after the Roman goddess of love. It shines with a brilliant, steady white light, hinting at a world that is fundamentally similar to our own, a twin sister to Earth, perhaps hiding lush tropical rainforests or alien oceans beneath its modest cloud cover. But that beauty is a lie. If you were to stand on the surface, you would not be looking up at a sky. You would be standing at the bottom of a planetary ocean. The atmosphere of Venus is composed of 96% carbon dioxide, compressed to such an extreme density that physics begins to warp. At the surface, the air does not behave like a gas. It behaves as a supercritical fluid. It flows like liquid, possesses the density of water, and creates optical refractions so severe that the horizon curves upward, placing the observer at the bottom of a vast, suffocating bowl. Here, the pressure hits 92 atmospheres, the equivalent of diving 1 kilometer deep into Earth's ocean without a submarine. And the temperature holds steady at 475 degrees Celsius, hot enough to make solid lead run like water. For decades, the West dismissed this environment as a technological dead end. But the Soviet Union saw it differently. They understood that Venus was the ultimate stress test for human engineering. They didn't just want to fly by, they wanted to touch the bottom. However, before they could build machines to survive this high-pressure abyss, they had to unlearn everything they thought they knew. Their first attempts were not acts of conquest, they were acts of supreme tragic overconfidence. The Soviet Union's greatest failure wasn't a rocket explosion or a guidance error. It was optimism. In the early 1960s, many prevailing scientific models of Venus were dangerously romantic. Because the planet is shrouded in highly reflective clouds, astronomers on Earth could not see the surface. In the absence of data, imagination filled the void. Leading theories proposed that beneath those clouds lay a prehistoric world, a steaming, swampy jungle teeming with primitive life, or perhaps a global ocean rich in dissolved carbon dioxide. It was the Jungle Venus hypothesis, a vision that promised a second Genesis right next door. When NASA's Mariner 2 probe performed a flyby in 1962, its radiometers detected alarming surface temperatures suggesting the planet was hot. But without atmospheric data, this was treated as a variable, not a verdict. The Soviets, driven by the ideological pressure to prove technological parity, bet their engineering on the hope that the Americans were wrong, bet their engineering on the hope that the Americans were wrong. They built their ships for a tropical storm, not a planetary kiln. This fatal miscalculation culminated on October 18, 1967, with the arrival of Venera 4. This probe was a marvel of its time, designed to act as a diving bell. Its engineers had reinforced the hull to withstand 20 atmospheres of pressure, a safety margin they believed was excessive for a planet they expected to be only slightly denser than Earth. As Venera 4 slammed into the atmosphere at 11 kilometers per second, it survived the initial thermal shock of re-entry. The braking parachutes deployed, and the descent module began its drift toward the surface. For the first few minutes, the telemetry was perfect. The probe broadcasted data on atmospheric composition, confirming a stark reality: an atmosphere dominated by carbon dioxide. The jungle theory began to evaporate instantly. But as the probe descended past the 28-kilometer mark, the environment shifted from hostile to lethal. The atmospheric density rose exponentially. The pressure outside the hull climbed past 10 atmospheres, then 15, then 18. At 20 atmospheres, the hull reached its yield strength. In a vacuum, structural failure is often silent. In the thick, fluid-like atmosphere of Venus, it was a sudden, mechanically driven structural collapse. The outer shell, overwhelmed by a compressive force equivalent to a heavy tank parked on a dinner plate, began to buckle. The metal didn't just bend, it sheared. Venera 4 suffered a catastrophic structural implosion. The hull collapsed inward, instantly crushing the instrumentation and severing the transmission. It never reached the surface. It was neutralized while still high in the sky, suspended in a crushing grip that its designers hadn't believed was physically possible. However, in its final milliseconds, Venera 4 achieved a victory of forensics. Before the signal died, the altimeter showed that the probe was still miles above the ground, even as the pressure maxed out the sensors. The data extrapolated a terrifying truth. The pressure at the surface wasn't 20 atmospheres, it was over 90. The Soviet engineers realized they weren't dealing with a planet in the traditional sense. They were dealing with a vertically extreme high-pressure atmospheric system. Venera 4 was crushed, but it sent back a number that changed everything. To return, the Soviet Union didn't need a better spacecraft. They needed a submarine. If the atmosphere of Venus acts like an ocean, the Soviet engineers realized they had to stop building aircraft and start building a bathyscaphe. The destruction of the early Venera probes forced a radical paradigm shift in the Lavochkin Design Bureau. The mandate was no longer about flight, it was about armor. For the next generation, starting with Venera 7, the engineers discarded the lightweight aluminum alloys that had defined the space age. In their place, they chose titanium. They cast the descent module as a single spherical pressure vessel. In engineering terms, a sphere is the only shape capable of distributing the crushing load of 92 atmospheres uniformly across its surface. The result was a machine that looked less like a scientific instrument and more like a cannonball. It was heavy, ugly, and incredibly dense. To ensure it wouldn't crumple like its predecessors, they tested it on Earth by submerging it in high-pressure hydraulic chambers, loading it to failure in high-pressure chambers, then reinforcing the welds that showed structural weakness. But armor only solved the pressure equation. The second killer was heat. At 475 degrees Celsius, standard electronics don't merely overheat. Solder joints fail, insulation breaks down, and silicon devices cease to function. Solder joints melt and silicon chips fail instantly. Since it was impossible to vent heat into an environment hotter than the ship itself, the Soviets devised a solution that was elegant in its brutal simplicity. They decided to delay thermal failure. They equipped the landers with a thermal battery system based on phase change materials, specifically using lithium nitrate trihydrate. This substance acts as a massive heat sink. Before separating from the orbiter, the lander would be supercooled to -10 degrees Celsius. Once it hit the Venusian atmosphere, the heat would have to work its way through layers of insulation and then melt the PCM before it could touch the electronics. The probe wasn't designed to reach thermal equilibrium with Venus. It was designed for controlled, time-limited operation. The mission duration was effectively a countdown of how long the ice could last in the oven. On August 17, 1970, Venera 7 was dropped into the clouds to test this new philosophy of survival. The descent was catastrophic. As the titanium sphere plunged through the upper atmosphere, the parachute lines, which were supposed to gently lower the craft, began to fail. Whether they melted or snapped under the aerodynamic load is still debated, but the result was a forensic nightmare. The parachute ripped away. Venera 7 entered freefall. On Earth, a fall from that height would have resulted in a supersonic impact that pulverized the craft. But Venus offered a strange mercy. Because the atmosphere behaves more like a dense fluid than a gas, the terminal velocity of the falling probe was drastically reduced. The heavy titanium egg didn't fall like a stone in air. It fell like a stone in water, plummeting. At about 16.5 meters per second, roughly 60 kilometers per hour, it slammed into the surface with an impact force far beyond what the mission designers had anticipated. The telemetry signal momentarily spiked, then vanished. In the control room at Baikonur, the engineers assumed another total loss. They began to file the paperwork for a crash site. But when they re-examined the background noise of the radio recording weeks later, they found a ghost. Hidden in the static was a weak, continuous signal. The probe had survived the crash. lying on its side with its antenna misaligned and its hull baking in the heat, Venera 7 kept transmitting for 23 minutes. It was the first time in history that a human machine transmitted data from the surface of another planet. The numbers were terrifyingly consistent: 475 degrees C, 90 atmospheres. The probe confirmed that Venus was indeed a pressurized furnace. 2 years later, Venera 8 repeated the feat, surviving for 50 minutes and confirming another crucial detail: the thick clouds did not block out all the sun. Light sensors detected a dim ambient glow, filtering down to the surface. It wasn't pitch black. This changed the mission profile yet again. If there was light, there could be sight. The Soviet Union had proven they could touch the bottom of the ocean. Now they became obsessed with a new, even more difficult goal. They wanted to see it. And that is when the ghosts appeared. In a world designed to crush everything, the most valuable commodity is not pressure data. It is sight. To see the surface of Venus is to stare directly into a forbidden zone, a place where the laws of optics themselves begin to bend. In 1975, Venera 9 attempted the impossible. It utilized a rigid aerodynamic braking shield, a circular metal disc designed to increase drag in the dense atmosphere, using the planet's own density to slow its descent without relying solely on fragile parachutes. It survived the landing and transmitted a single black and white panorama. The image was a shock to the geological community. Expecting a landscape smoothed by erosion like Mars, scientists instead saw sharp, jagged rocks. The piles of stone were angular and fresh, suggesting that the surface was geologically young. The angularity suggested limited erosion and relatively recent geological processes. But the true sensory awakening arrived in 1982 with Venera 13 and 14. These probes were the pinnacles of the program, equipped with color cameras and microphones. The photos they returned depicted a world bathed in a sickly, omnipresent orange glow. This wasn't a camera filter. It was physics. The atmosphere is so thick that it preferentially scatters shorter wavelengths, heavily suppressing blue and green light, leaving only the red and orange wavelengths to reach the ground. If you stood there, you would see no shadows, only a diffuse glowing fog that obliterates depth perception. Even stranger is the optical distortion, because the atmosphere has extreme density and refractive index gradients, or bends severely as it travels through the air. This creates a fishbowl effect. If you look toward the horizon, the ground would appear to curve upward rather than downward, placing the observer at the bottom of a vast, shallow bowl. You would feel trapped not just by gravity, but by the light itself. Venera 13 also managed to record audio, the first sounds ever captured from another world. It wasn't the roar of a monster, but a low aerodynamic rumble. It was the sound of wind pushing against the titanium struts, a lonely mechanical wind blowing through a graveyard of rocks. However, the chaotic nature of this data eventually birthed a ghost. Decades after the missions in 2012, Russian scientist Leonid Xanfomalidi re-examined the archival tapes from Venera 13. In the grainy, noise-filled panoramas, he identified an object that he claimed emerged, moved, and disappeared over the course of the transmission. He called it the Scorpion. To the untrained eye, the blurry shape does resemble an arthropod, but forensic engineering demands we separate wishful thinking from digital reality. When analyzing analog telemetry from the 1980s, we are dealing with extremely low bit rates transmitted over 40 million kilometers through a highly charged atmosphere. The Scorpion aligns perfectly with the known behavior of signal artifacts produced by analog to digital reconstruction and line scanning errors and signal degradation. Furthermore, deeper analysis of the probe's schematics suggests the object coincides with the ejection path of the camera's lens cap, which was blasted off by pyrotechnic charges upon landing. What Xanfomalidi experienced was pareidolia, a psychological phenomenon where the human brain, desperate for pattern and meaning, imposes a familiar shape onto random noise. We see faces in clouds, and we see scorpions in the static of a dead planet. The probe didn't record life. It recorded the chaotic decay of information. The movement was simply the result of image processing artifacts shifting as the camera scanned different lines. The Scorpion was debunked, but it highlighted a profound truth. We want Venus to be alive so badly that we are willing to hallucinate. But Venus offers no such comfort. It is a sterile geochemical engine. And while these robotic explorers were dutifully sending back unprecedented sensory data from the surface, the humans who built them were preparing for something far less noble in orbit. While the probes were armed with cameras, the stations above were being armed with guns. Venus was not just a scientific target. It became the only remaining arena where the Soviet space program could still demonstrate technical dominance. To understand the desperate intensity of the Venera program, we must look at what was happening back on Earth. By 1969, the symbolic objective of the space race, the first human landing on the moon, had been claimed by the United States. Their massive N-1 rocket, a heavy-lift launch vehicle designed for lunar missions, had failed 4 times in spectacular explosions. With the Americans walking on the Sea of Tranquility, the moon was symbolically lost. The Kremlin needed a victory that the West hadn't claimed. They turned their gaze to Venus. Venus became a domain where no prior human achievement existed, allowing the Soviets to define the terms of success, a theater where they could prove that Soviet engineering was still superior, even if they couldn't land a man on the moon. But while the Venus missions were physically real, the Soviet lunar ambitions retreated into a paper empire. Deep within the archives of the era lie the blueprints for Project Zvezda, an internal concept study for a modular lunar base sometimes referred to in later literature as Barangrad. It was a fully detailed plan for a permanent lunar base complete with 9 modules, nuclear reactors, and living quarters buried under the lunar regolith to protect against radiation. On paper, it was a magnificent vision of colonization. In reality, without a working heavy-lift rocket, it remained a fully developed design that was never operationalized. However, Cold War threat assessments led to design decisions that prioritized military contingencies, even in orbit. While the Venera probes were peaceful explorers, the Soviet presence in Earth's orbit was arming itself. The Almaz military space stations were launched under the guise of the civilian Salyut program. But Almaz 2, also known as Salyut 3, carried a secret payload, a modified Richter R-23M aircraft cannon. It remains the only firearm ever test-fired in space. Here, the physics of orbital warfare reveal their absurdity. In the vacuum of space, Newton's third law is absolute. For every action, there is an equal and opposite reaction. When the cannon fired a 23mm shell, the recoil force didn't just shake the gun. It pushed the entire 20-ton space station backward. To fire the weapon without knocking the station out of its stable orbit, the thrusters had to fire simultaneously to counteract the recoil. It was a delicate, terrifying balance. The Soviets were effectively flying a fragile pressure vessel, armed with a machine gun, preparing to shoot at American interceptors that didn't exist, while simultaneously deploying uncrewed scientific probes to acquire extreme environment data on the surface of Venus for the sake of pure science. This dichotomy defined the era humans were willing to bring war to the stars, yet they were also capable of the supreme patience required to characterize the most extreme planetary surface ever measured. Eventually, the Cold War thawed. The Soviet Union collapsed. The funding for interplanetary sieges evaporated, and the Venera program ended with a whimper in 1984. We stopped going back. We assumed that without us, the story of Venus was over. But we were wrong. The political machine stopped, but the planetary machine did not. In the silence of the last 40 years, new data indicates that Venus has remained geologically active. We often make the mistake of thinking that because Venus is hostile to life, it is a dead world. We imagine it as a static, frozen tomb of rock. But we were wrong. Venus is not dead. It is energetically active. Even high above the crushing plains, the planet exhibits an extreme form of high-temperature atmospheric chemistry. In the 1990s, radar maps from NASA's Magellan orbiter revealed a strange anomaly on the slopes of Maxwell Montes, the planet's highest mountain range, which towers 11 kilometers above the surface. The radar returns from the peaks were incredibly bright, suggesting they were coated in something reflective. On Earth, mountain peaks are capped with frozen water. On Venus, the temperature at that altitude drops just enough for heavy metal vapors in the atmosphere to condense. Instead of water ice, radar data suggests the condensation of high reflectivity compounds, such as lead sulfide and bismuth sulfide. The highest peaks of Venus are capped in a layer of heavy metal frost shimmering like mirrors in the radar darkness. but the real movement is happening below. For decades, planetary geologists debated whether Venus was still volcanically active. The planet has no tectonic plates to release internal heat like Earth does. Instead, internal heat accumulates in the mantle until it is released through episodic, large-scale volcanic resurfacing. Heat builds up inside the mantle until the entire crust becomes unstable, leading to catastrophic global resurfacing events periods, where the entire planet turns inside out, flooding the surface with fresh lava and erasing all craters. We thought this happened millions of years ago. But in 2023, the verdict changed. Researchers Robert Herrick and Scott Hensley reanalyzed grainy radar data from the Magellan mission taken 30 years prior. They performed a forensic comparison of two images of the Mont Mons volcano taken 8 months apart. In the first image, a volcanic vent was circular and deep. In the second image, the same vent had expanded, become kidney-shaped, and filled to the brim. The most plausible interpretation is that sometime in 1991, a massive eruption occurred. The crust broke open and a lava flow covering tens of square kilometers was emplaced on the surface. This confirms that Venus is a thermodynamic engine in constant flux. It is a self-regulating thermodynamic system that releases internal heat through episodic volcanic processes. The sulfur in the clouds, the acid in the rain, and the heat on the surface are all byproducts of a planet that is constantly recycling itself. The Soviet probes didn't land on a rock. They landed on a geologically active surface undergoing continuous thermal renewal. The realization that Venus is geologically active changes the context of the Soviet sacrifice. They were studying a dynamic, evolving world. Their data points were snapshots of a planet undergoing a period of active geological transition. Now, almost 50 years after the last Venera transmission faded, humanity is finally preparing to go back. But this time, we aren't going to prove a point. We are going to test whether modern engineering can operate within the limits that Venus has already defined. Today, the physical remnants of the Venera landers are likely gone. The titanium pressure vessels that survived the drop have likely been chemically degraded by long-term exposure to sulfuric acid aerosols or buried under fresh flows of basaltic lava from the eruptions of Mont Mons. The hardware has been reabsorbed into the planet's geochemical processes, but the data remains. For nearly 40 years, humanity turned its back on Venus, favoring the dusty red horizons of Mars. Mars is easier. Mars offers the seductive promise of colonization, a potential second home. Venus offers a boundary condition. It is Earth's evil twin, a planetary memento mori, showing us exactly what happens when a greenhouse effect spirals out of control. It is a mirror that reflects a future we must avoid. Now that silence is ending. In the coming decade, a new fleet of explorers will launch toward the morning star. NASA's DAVINCI mission will drop a probe through the clouds to taste the chemistry of the atmosphere. Veritas and ESA's Envision will map the surface with radar resolution far sharper than Magellan. But these modern missions are not flying blind. They are navigating by maps drawn in the 1970s and 80s. They are building directly on the empirical limits established by the Venera program, who first subjected hardware to sustained operation within Venus's extreme environment. Every calculation NASA makes for heat shielding, every pressure tolerance for the new probes is built upon the forensic lessons of the Venera failures. The Soviet space program is often criticized for its recklessness, for the secrecy, and for the frantic pace that led to the N-1 rocket disasters. But on Venus, they achieved results whose value persisted beyond the political system that produced them. They didn't just build machines, they developed a repeatable methodology for operating under known failure conditions. They accepted that the environment was stronger than them, and they adapted. They moved from aluminum to titanium, from static landings to cooling agents, learning to trade metal for minutes. In the end, the story of Venera is not about the Cold War. It is about the persistence of inquiry under hostile constraints. Venus didn't defeat the Soviet Union. It forced them to invent a new way to fail slowly, deliberately, and with data. It taught us that in a universe indifferent to our existence, the only true victory isn't planting a flag. It is surviving long enough to tell the story.